Okay, now the reason I needed you to understand how to change the enthalpy is for questions like this. If you look at question number 23, it says calculate the heat required to melt 25.7 grams of solid methanol at its melting point. So that means if you are given the table, you have to go and look up the fusion value for solid methanol, like what is going to take, how much energy is it going to take for it to melt. So when you go to the table, you see yes, methanol, and to vaporize it, that means evaporation to take place, it's going to be 35.2. Now we're not vaporizing, we're melting it. So melting means fusion. So this is the value. I'm going to need 3.22 kilojoules per mole of methanol. So if you go look at the question, you see that I've added it in here. My change in enthalpy for fusion is 3.22 kilojoules per mole. I'm writing it as a positive value because remember, when we have melting from solid to liquid, we call it fusion. So I will go look up the fusion value. Now, if I was freezing it, then I would have used the same value, but just put the negative in front. But now we are melting. Melting means it's endothermic. It's a positive value, so delta H is positive. I need this value in order to be able to complete the calculation. So if you look at the question, I need to find out how much heat I'm going to need to melt this mass. So my delta H tells me I need 3.22 kilojoules per mole. I don't have my value of methanol in moles, but I have it in mass. So that means I can use relative atomic mass values to calculate what is the number of moles I have. So if I have 25.7 grams, I can find out how many moles I have. So I first determine my molar mass, meaning adding up all my relative atomic masses. Carbon is 12. I have 3 times the hydrogen, 3 times 1. Oxygen is 16, plus that extra hydrogen 1 gives me 32 grams per mole. So the number of moles is my mass divided by my molar mass. 25.7 divided by 32 gives me 0.80 moles. So now I know how many moles of methanol I have. Now, according to my enthalpy value, I need 3.22 kilojoules of energy for every 1 mole. So 1 mole, I need 3.22 kilojoules of energy. From that 1 mole, from this rule, I can come up with these 2 conversion factors. This over that, or this one over that one. That means I can now take this answer over here, 0.80 mole, and I can use the correct conversion factor to convert my number of moles to my kilojoules. So 0.80 mole over 1, I need to make sure that if I have mole on the top, there's a mole at the bottom. So I now go and find the conversion factor that will fit there properly. This is the only one. I can't use that one. It doesn't have mole at the bottom. So I will use this one, which is 3 times 3.22 kilojoules over 1 mole. If I multiply that out, I see that 2.58 kilojoules of heat is required to melt this methanol. Now, question number 24 is literally an opposite to this one. This one says how much heat evolves when 275 grams of ammonia gas condenses. Now remember what I said to you. When we look at liquid to a gas, I talk about vaporization, and I can use my table to look up the vaporization for ammonia. And I see that ammonia to vaporize is 23.3 kilojoules per mole. So in this question, I'm not going to vaporize the ammonia gas. I'm going to condense it. So that means I will use my vaporization value of 23.3 kilojoules per mole, but to write it as change in enthalpy for condensation, I just put a negative in front, because in this question, I'm not vaporizing ammonia, I am condensing it. So all I do is I use the vaporization value, but because I'm condensing, I put a negative in front, because condensation is the opposite of vaporization. The question is exactly the same as the previous one. I will take the mass of ammonia and work out how many moles I have, because my enthalpy value is kilojoules per mole. So I need to know how many moles I have. So I will find out my molar mass first for ammonia gas, which is 17 grams per mole. Then I change it into number of moles, which is the 275 divided by that 17, gives me 16.8 moles. Now I will go and I take that value and I will convert that and see how many kilojoules I have. So because I'm using this rule over here that says 1 mole of ammonia is equal to negative 23.3 kilojoules, I can come up with these two conversion factors. I then take the 16.8 moles of ammonia and I will convert it to kilojoules. Remember, I've got moles on the top, there must be mole at the bottom. If I multiply this out, I see my answer is minus 375.91 kilojoules. The negative sign means heat is given off. I need heat to leave the system so that the ammonia can go from a gas phase to a liquid phase. So that means my final answer will be 376.91 kilojoules of heat is released. This is the kilojoules. I needed to divide this by 1,000. No, sorry. It's 376.91 kilojoules of heat is released. So I do not write the negative in front. The negative just tells me it's exothermic. The negative also just tells me that heat is being released. So this is the amount of energy that's released when I go and I condense ammonia gas from a gas phase to a liquid phase.